Everyone, my name is Madeline, and I'm the energy storage manager at Soligent. And you know, I've this is probably my, I don't know, 10th plus webinar, and it's funny that I haven't brought up AC and DC coupling before. We've had so many other different, questions or bullet points to discuss. So I'm really excited to talk about kind of a fundamental technical element of storage related equipment. So without further ado, we'll dive right in. So I'll just tell you a little bit about myself and kind of my role and how I help serve account managers and our customers at Soligent, and then just dive right into the fundamentals of AC coupling and what solutions Soligent has amongst that equipment, and then the same thing for DC coupling. And I will pause for any questions, kind of a Q&A after AC coupling, so that we can kind of get all of our AC questions answered before we transition into DC coupling. So hi again, my name is Madeline, and I have been working in the solar plus storage space since 2016. Hard to believe it's been that long now. Really kind of when we started there, the focus at the time was definitely more off-grid installations. The grid tie battery backup was a little bit less common. And recently, I would say last year and the beginning of this year, we've had so many great different brand offerings with both AC and DC coupled solutions. So whether you're still in an off-grid setup or if you're grid tie and you want some resiliency, we really have so many different technology offerings to serve any homeowner's needs. So really excited to dive into a lot of those today. My goal is to support installers to understand storage, understand how to talk about it with their customers and feel confident pitching it, and confident kind of coming up with a solution that will fit your homeowner, because there's a lot of different moving parts when you add a battery to a traditionally PV only system. So my goal is to work with all of our different brands to support a battery-based installation, and I'm happy to help kind of communicate between an installer and your end customer if need be. So, feel free to pick my brain anytime you want with technical or sales related questions. So let's start with AC coupling. And what does it mean when we say AC coupled? So the first kind of fundamental thing I want to look at in this diagram is that when you start with your solar panels, they are paired to a PV inverter, just like you're used to. So in a traditional setup, you would have your solar panels, your grid tie inverter, your meter, which feeds your home, and the grid. Great. That's kind of your traditional setup. Then when you decide with this sort of setup, if you want to add a battery system, you're going to install an additional hybrid inverter. And this additional hybrid inverter is what identifies an AC coupled versus a DC coupled system. So in total, you have two inverters, one grid tie inverter that pairs your PV to your meter, and a hybrid inverter, or also known as a battery-based inverter. And that's what ties in your battery into the system. So our different offerings for AC coupled solutions include N-phase, and the N-phase storage kind of features the N-Charge and the N-Power products. Outback Skybox, which is also an AC or DC coupled piece of equipment, and we'll talk about it twice. Panasonic Everbolt has both AC and DC coupled solutions. You can AC couple with Schneider. I want to mention Soligent Arc, which also similar to the Skybox, the Soligent Arc can be AC or DC coupled on the same device. Sonin, which is a prominent AC coupled only solution, and then the SMA Sunnyboy Storage. So I want to go into a little more detail on what are the features of AC coupling. So common for retrofits. If you already have a system, let's say it's 3 years old and you want to add batteries, your warranty is going to still last for your grid tie system for a couple more years. So there's no need to remove any of your equipment. You're simply adding the hybrid inverter and the battery to your existing system. Enabled by frequency shifting. So frequency shifting is a buzz phrase, if you will, for AC coupling. And what does that mean? So when your house is drawing power, in a typical setup, it would either be taking that from the solar panels or from the grid. But when the grid goes down, the relationship goes from your home to the solar panels or your home to the battery bank. So in order to ensure that your hybrid inverter is drawing and discharging and charging from your battery to your house efficiently, you want to make sure that the communication between your hybrid inverter and your PV inverter is sound. And this is a really important concept. So frequency shifting is the way your hybrid inverter communicates with your PV inverter. So if your battery bank is full, the sun is shining, and you're not, let's say it's a vacation home and you're not home and there are very few loads drawing anything. You don't want your hybrid inverter to be getting pummeled with PV because there's nowhere for this power to go. So your hybrid inverter has the ability to dial up the frequency, and when the PV inverter sees this happening, it starts to reduce the power output. And that's what frequency shifting means. It says as the hybrid inverter toggles up the frequency, so meaning typical grid frequency is 60 hertz. So if you start at 60, you'll, let's say, go up to 60.5. When the PV inverter sees, I'm receiving a frequency of 60.5, I'm gonna turn down a little bit. And this motion happens over and over until the house loads are met and the battery isn't being charged with additional power. So it's really a give and take to make sure that the power is balanced between your PV inverter, your loads, and your battery. The one caveat to AC coupling is that because you're converting AC to DC multiple times, you may be experiencing lower total system efficiencies because your house is using alternating current, but your battery is producing direct current and your PV is producing direct current. So you have to go from DC to AC to go to your house, and then from AC to DC again through the battery. So by doing this power conversion multiple times, the efficiency goes down. So that's sort of the drawback, if you will. And Jamie, I am seeing some notifications coming in, likely it's in the chat box. Let's talk about any questions at the end of me reviewing the different brand offerings, because it's possible that I will answer your questions when I talk about each of our different options and kind of how they differ. So yeah, is that okay?
Absolutely. Thank you, Madeline.
Great. I'm going to go over kind of each of our AC coupled options and kind of how they're similar and different, because you know, every brand has their little kind of nuance to why they are different. Okay. Let's start with Enphase storage. Enphase storage is unique, and I want to start by saying they are a distributed architecture storage solution. So similar in the sense that they use microinverters to provide power for each of their panels. They use a distributed architecture to use storage in multiple units. So here we start with our PV panels, and those are paired with either an IQ6 or IQ7 product line. As of today, you can also pair Enphase storage with the M series. So with a little bit of Envoy firmware upgrade, M series will also work. So we go to the IQ combiner, which then goes into the smart switch. The smart switch is really a unique product to Enphase. It's the Enphase load center, if you will. So it's where all of the AC from your house and from your battery and from your PV will come in. And the reason why I'm saying it's all AC is that Enphase is an alternating current technology, meaning by having microinverters at the roof, you're running AC right from the roof. Similarly, The N-Charge batteries also have microinverters inside. So this is a very unique defining feature to Enphase, is that although there are also battery modules, there are microinverters inside. So the output of the battery unit is also AC. This is unique to Enphase. So we have all of these AC outputs coming into the smart switch, and your smart switch is kind of your little hub for everything. This is also where you're going to connect, in this case, your critical load panel, where your backup loads are, and also the main load panel, which would just be passing through when the grid is up. So the two defining hardware components for Enphase storage would be your N-Power smart switch and your N-Charge batteries. And the N-Charge batteries come in a 3 kilowatt and a 10 kilowatt size. So you can go 3, 6, then 10 with your bigger guy, up to 40 kilowatt hours. So you can do between 3 and 40 kilowatt hours on a single smart switch, which in most cases, 40 kilowatt hours is absolutely sufficient to provide backup for a house. If you need more than that, that's fine. You would just add an additional smart switch and put that on its own sub panel. So 2 smart switches would be running 2 independent systems of each other. That's our Enphase storage spiel. Oops, backwards. Okay, shifting to the Sunnyboy Storage. This is actually a snapshot from the automatic backup unit data sheet, and the automatic backup unit is in some ways similar or comparable to the N-Power smart switch. The automatic backup unit is the grid forming device where all of your different loads and power sources are coming together. So they also have this kind of mapped out so we can see what's going on. We have the energy meter built in to this. Then you have your PV breaker and your Sunnyboy storage breaker, so you know where everything is landing. And it says PV inverter, so this makes it clear that this automatic backup unit device is for an AC coupled solution because it has an input for the PV inverter rather than a PV only input. So that's something to denote. So let's just go through the diagram a little bit. We start with the PV and we go to the Sunnyboy, a great traditional string inverter, PV inverter, grid tie for SMA. Then the AC output is going to go into the automatic backup unit. Great. We're going to feed our house loads. This also is going to be fed from the Sunnyboy storage. So in our case, we're also going to have this battery-based inverter. So we have the battery-based inverter pairing the batteries here, the Sunnyboy storage, and the PV inverter, which is the Sunnyboy. You can have up to 3 BYD batteries on a single Sunnyboy storage, and those are 10, 20, and 30 kilowatt hour segments. So the smallest that we would provide is 10, and the largest is 30 for a single load panel. And something cool about the automatic backup unit is even though the Sunnyboy storage inverter sizes are 3.8, 5, and 6 kilowatts, the automatic backup unit can output up to 50 amps. So you can pair up to 9.6 kilowatts of PV and this AC coupled setup. And this is unique because some of our other options moving forward have a limitation to less PV being paired. So the SMA Sunnyboy storage, if there's one takeaway you have from this technology, it's that you can pair up to 9.6 kilowatts of grid tie PV onto the automatic backup unit. And this is a large amount of AC coupled PV. Okay, moving on to a new solution, the Sonin Core. So this is a brand new setup from Sonin. You may be familiar with their Eco and their Eco Links. Those are also AC coupled options. And we are going to have the Sonin Core units hitting our warehouses, I think, by the end of this month. So keep your eye out. Definitely make sure you're getting a quote from your account manager because since these are brand new, we expect these to really go quickly. So this is a single line diagram, very similar setup to what we've seen before. However, everything is in one box. So for end phase, we have the smart switch and the battery units as separate components. With SMA, we had the automatic backup unit, the Sunnyboy Storage inverter, and the BYD batteries, also separate units. With the Soligent core, it's all in one box. So let's go through this diagram also. These vertical little squares are our PV diagrams going into a PV inverter, tied onto a protected load panel, critical load panel, backup load panel, whatever you want to call your sub panel. And then this is going to tie into your Soligent core. So this Soligent core diagram includes two 5 kilowatt hour lithium ferrophosphate batteries. So you have a 10 kilowatt hour system with the Soligent core, and the output of the AC power is 4.8 kilowatts continuous and an 8 kilowatts surge. So it's a 4.8 kilowatt, 10 kilowatt hour option. And then the output of this would just feed your main panel. So the Soligent core is really nice. It's a very affordable solution. So I encourage you to reach out to your account manager to get a quote. It is an indoor rated unit. And it's sleek. It's smaller than any other Soligent unit before. So it's easy to install with just the enclosure that also already has the inverter in it. And then you install the two battery modules separately. So it's lightweight, easy to put in. Really, really excited about this new option. And with this option, I do want to mention for AC coupling, it has up to 6 kilowatts of grid tie PV. So if you have someone that has, let's say 10 kilowatts of grid tie and they want to add storage, you may want to consider a different option. But if you have someone with a 5 kilowatt grid tie inverter, perfect. Soligent core will pair great with that. So when AC coupling, it's always important to keep in mind how much grid tie PV you want in the system in order to make sure your hybrid inverter is appropriately sized. Panasonic Everbolt. So this is a single SKU solution similar to the Soligent core where you're just buying one piece of equipment, but it is separated into two boxes, the Everbolt inverter component and then the Everbolt battery enclosure. And the reason why I want to just go through each of these wiring diagrams is so that you can see how different brands use schematics, line diagrams, electrical diagrams, however you want to call these, because they do them a little bit differently. And I look at these probably every day. It's really helpful if you can easily digest a wiring diagram. So if that's something that you feel a little uncomfortable with, maybe absolutely reach out and we can kind of review how do you look at the power flow, because understanding kind of where things move in and out of the system is really valuable to also explain to your customer. So starting with the PV, Panasonic Evervolt AC version. PV panels paired with microinverters. If you already have a string inverter system, that's okay. It's just making sure that you know that the PV panels are grid tied on their own. This is going to feed a central load panel, great protected load panel, what you want to call it, and that's going to feed your Evervolt inverter. The Evervolt inverter is going to connect to the Evervolt battery, and then output is to the main where the grid comes. Great. So with the Panasonic Evervolt, the two sizes are the standard and the plus. The standard is 11.4 kilowatt hours and the plus is 17 kilowatt hours. So those are your kind of two options. I would say the standard is if you just have, modest essential loads, lights, fridge, Wi-Fi, TV, ceiling fan. And then if you look at the difference between the 11.1 and the 17 option, you could use those exact same loads and still opt for the plus, but that's because you're getting a more time. So the inverter size is going to indicate how much instantaneous power, meaning how many loads you want, but the size of the battery bank is going to dictate how long those loads can run. So again, I'll say that one more time. The inverter is the quantity and the size of loads, and the battery is for the duration of those loads. Outback Radian. This is the wiring diagram, I believe from their quick start guide. So Outback has very, very detailed, you can see they have their neutral, their DC line, positive and negative, and their ground. So it's very, you'll know exactly where each wire goes because each wire is included on here. So let's go through this Radian. We start with the PV and we tie into a grid tie inverter, which is the start of every one of our AC coupled solutions. Then this is going to go into the wiring box of your Radian down here. And the wiring box of the Radian is called the GSLC. And that stands for, so the Radian line is called the GS. So your Radian is a GS4048, which means it's a 4 kilowatt, 48 volt DC option. And then the GSLC stands for GS Load Center. So we're going to wire our the PV grid tie inverter output into here. We're also going to have our battery bank landing into this load center. So everything is going to be housed in the GSLC, which is immediately wired underneath the Radian. We also have a generator input if you need that. And then the AC output is going to go to your sub panel. So the Radians come in a 4 kilowatt option and an 8 kilowatt option. So the Outback Radian is different than our other solutions because this is really an inverter option. So you know that you're going to be getting 4 or 8 kilowatts of output, but your battery bank has a lot of flexibility. Any 48 volt battery bank will work in this setup. So that might be a 48 volt flooded bank, a 48 volt gel bank, a 48 volt lithium bank. So depending on what battery chemistry you select, there will be a different set point to program. But the flexibility is really nice so that you can do any kilowatt hour size for your Outback Radian. There is a minimum requirement, so just be conscientious when you're sizing the 4 or the 8 with a minimum, but in terms of a maximum, it would be hard to oversize a Radian. Similarly, we got the Schneider XW. These are both kind of historically off-grid solutions, but they absolutely work as grid tie options with a grid tie inverter. So this is a little bit more of a kind of bare bones diagram, if you will, compared to a wiring diagram. So we start with our PV and our PV inverter landing on a critical load panel, which is going to feed our critical loads with alternating current. Then we have our XW inverter. So the XW plus line was the original line, and it is being transitioned to the XW Pro. So you probably are familiar with Schneider XW Pro, but the Pro is going to be the inverter moving forward. And then we have the AC main panel and the grid. So relatively similar setup. With the Radian and the XW, you can stack. So what does that mean? If you have a system and they need 20 kilowatts of power, or let's say they have 20 kilowatts of grid tie PV and they want all of those panels to stay active when the grid goes down, you can add multiple inverters. So with your Radian, we just have multiple Radians with multiple GSLCs. And then with the Schneider, you would have multiple XW Pros. With the load center equivalent for Schneider is called the power distribution panel. So you would have multiple XW Pros with, you can put, I believe, 3 XW Pros on a you would have 1 PDP, and then you would get an inverter extension cabinet, if you will, to enable the stacking. So these are great options if you have larger loads that need to be met with more kilowatt power.
And someone out of California just shared a gorgeous, exceptional Radian install, and it was paired with Simplify battery bank. So we always look forward to everybody sharing their installs with us. That was a really nice one.
Pictures are like the best thing because, you know, I talk about all of these wiring diagrams, but it's so nice to see like these beautiful installs in real life.
Absolutely.
So SolArc is one of our newer offerings, and we actually did a webinar on SolArc yesterday. So this is one of our AC or DC coupled options, and we're going to review how this works. It's a little bit different. This diagram is a little bit harder to understand because if we're looking at the AC coupled version. So here I want to focus on in this big rectangle is our inverter. And in the upper right corner, this is going to be our AC breakers. So all of our AC breakers are up here together. The AC in and out load, the generator, and the load out. So this is where you're going to land your AC coupled PV because the output of your grid tie inverter is AC. So that's why you're going to be putting it on the AC bus. Here they have the PV, and this would be if you were using the DC PV input. So in our case, we would not be using this input because we don't have any direct PV plugging into the inverter. In our case, we have the grid tie inverter output, which is alternating current. So for the SolArc 12, it's called a 12 kilowatt unit, but the continuous off-grid output is 9 kilowatts. The reason it's called 12 is because if you have an additional output from the generator, let's say, you can have a total output of 12 kilowatts. But the battery only, inverter only output would be 9 kilowatts. Again, this is a stackable unit as well. So if you have larger loads that need to be met, this is a great solution. The one thing I like about SolArc a lot is that you can do a lot of different things with a single SKU. So the 12 kilowatt unit is an indoor or outdoor rated unit. It supports generator integration. It supports AC or DC coupling, and also it supports AC and DC coupling simultaneously. So if you have, let's just say, a 3 kilowatt Sunnyboy, and you want to add another string of PV, that is very doable. So you would put the 3 kilowatt output into the AC coupled PV input. Oh, I hope you can't hear the dog barking out there. And then you'd have the PV string going directly in. So that is that. Let's keep going.
The dog agrees it's a great solution.
Outback Skybox. So this is another kind of bare bone. It's funny to think about the two Outback schematics looking different because the Skybox, this little diagram is so bare bones. Again, really just in diagrams and icons compared to the Radian, which has every single wire and where every single wire lands on each breaker. So get some variety. We have the PV. Here's our grid tie inverter, and this is going to be going into the Skybox. And again, we're using a critical load panel in almost all of these AC coupled solutions, just because it's really helpful to back up the critical loads, only what you need at a given time, rather than your whole house. And for people who do have whole house backup needs, we can definitely address that, but it sometimes requires multiple inverters and definitely a load evaluation so that you make sure you're sizing everything accordingly. With the Skybox, in a different way from the Radian, the wiring box is already pre-installed. So it's, again, below the inverter, just like the Radian, but it's attached to the Skybox. So this is where all of your DC and AC input and outputs go. Then the output is going to go, here's your main panel, and then the grid. So with the Skybox, it's similar to the SolArc in the sense that it's sort of an all-in-one box. You can stack two. So the maximum amount of kilowatt output with Skybox you would have is 10 kilowatts. Again, with both of these solutions, similar to Outback Radian and Schneider XW Pro, it is battery agnostic. So whatever your 48-volt battery bank desire is can work for either of these or all 4 of these solutions. So lots of flexibility for design in terms of battery chemistry and battery bank size. So that's a really nice feature. Okay, AC couple questions time. I'm ready.
Anybody want to pop in a question in the chat box? Feel free, but you've answered majority of these questions, Madeline, so we are good on that front. But feel free, use the Q&A or chat, whatever you're more comfortable with.
Sure, I'll just take a moment to kind of review how things have gone. So with Enphase, again, it's an all-in-one brand solution also. So in addition to their distributed architecture design, it's all under one name. So if you have Enphase microinverters, all of your monitoring is through the Enlighten app. So you don't have to worry about having 2 different technologies. Because here's another example. Let's say you have a Fronius inverter and you want to add a battery bank. You would have your Fronius monitoring, and then if you add a Schneider Pro, you have your Schneider monitoring. So then you have 2 different technologies communicating with each other. Because of the frequency shifting, they're able to work together in your whole house system, but you know, it's just something to take into consideration, you know, in the back of your mind. With Outback, you can have an Outback battery also. So you could stick to a single brand in that regard, but you just want to be conscientious of how many brands do you want in your house, and if that is something that is an issue to you, take that into consideration. All right, I am going to move on to DC coupling, which is a somewhat more simple technology, if you will. So let's start with the original. DC coupling, this is kind of the old school approach. This has been around for decades. So many people have a setup similar to this on their home. And why is it great? So because you don't have a PV inverter in this case, you need to have a way to regulate the PV. And how do we do that? We regulate the PV with a charge controller. So the solar panels are, because they're creating DC power and the battery bank is creating DC power, the charge controller is the communicator. It is kind of the roadway that says, give and take, you know, feed and discharge. So with these 3 brands, you're going to have an external charge controller. So if you're using Outback, the Outback Radian, the Flex Max is going to be your charge controller line. So Outback has the Flex Max 60, which is a 60 amp, the Flex Max 80, and the Flex Max 100. So the 100 is the biggest. I'm not going to even, off the top of my head, I'm not sure how many kilowatts, but you can, it's almost as much as you can have 1 charge controller on a single string. So it makes things easier if you have a lot of PV. You can just use an FM 100 and put everything on that. So the PV and the battery are all communicating through direct current together. Then they're going to the inverter and converting to AC. So you're only doing our DC to AC conversion a single time. And that is why the efficiency for these systems is sometimes higher, because your inverter only has to do this conversion once. The DC is regulated through the charge controller, and then the AC from your home is taking that from the hybrid inverter. You have a single hybrid inverter that is doing all the conversion for you. With Schneider, they have the 8600 is the nomenclature for that. It's an 80 amp, 600 volt. There's also a 6150, which is a 60 amp, 150 volt. So I kind of did that a little backwards, but the 8600 is essentially a high voltage stringing charge controller. So it's similar to the way you've been used to stringing a string inverter. There also is a new 100 amp. So 100 600, I guess is the way you would say it, charge controller. So that's even bigger than the 8600. So definitely take a look at Schneider's new charge controller. Magnum has the PT100, which is another large charge controller. So really lots of options here with how much PV you need to tie in. The new version of DC coupling is with an integrated charger. So this makes your life a little bit easier because the charge controller function is installed into the hybrid inverter. So you're able to tie your PV straight into your hybrid inverter. You don't need to wire an additional charge controller to still have charging function. So with Generac, and we'll go into each of these a little in more detail, but Generac is a exclusively DC coupled option. So you're only going to have one inverter on your system. The Outback Skybox is showing up again because you can have direct PV into this inverter. Panasonic has a secondary model. So they also have the standard and the plus, but it's in a DC version. Solar Edge, as you know, is the DC optimized inverter that's been around for a long time. So their storage solution is DC coupled as well. And then Solar Arc coming back again because Solar Arc has the same thing is similar to Skybox. All of the inputs can go into that single unit. So without further ado, I would say both of these are still DC coupled solutions. One just has a external charge controller and one has a built-in charge controller. Okay. So I've distinguished the DC coupled in a few different categories. And the first one is with integrated rapid shutdown, meaning rapid shutdown compliant devices are part of this brand. So with Generac, you have your array and it's feeding into the PV link. And a PV link is a string level optimizer. You can pair between roughly 2 and 9 panels per substring optimizer. So it's approximately up to 2.5 kilowatts. If you need module level rapid shutdown, you can also install a snapper. It's called like Snap RS, meaning Snap Rapid Shutdown. And it's an inline like MC4 extender, if you will, and that enables rapid shutdown compliance. So PV to the PV link, and then that's going to land on one of the 4 DC inputs. So this is really interesting that because this is a DC coupled solution, the DC ports are really flexible. We have 4 30 amp DC ports. And if we're going to do an example of like a quote unquote maxed out solution, we could do 2 of these ports with PV and 2 of the ports with batteries. So what would that look like? We can do up to 3 PV links per input. So that would be a total of 15 kilowatts. So you could put 15 kilowatts on a single 7.6 kilowatt inverter. And you might think, goodness, that sounds like a lot of PV on one inverter. Why am I doing that? And the DC to AC ratio is a little bit different when you're thinking about batteries, because when you're DC coupling, the first priority of the PV is charge my battery bank. Charging your battery bank is the first priority of this system. So any PV you have is going to go straight to charging your battery bank. Then if you still have loads running, you can feed the loads with the PV as well. So oversizing it really is advantageous because it prioritizes your battery charging first, which is a really, really good feature. Then if we were to do the second 2 DC ports with batteries, the power cell batteries have up to 17 kilowatts per enclosure. So that would be 34 kilowatts. So we would have 15 kilowatts of PV, a 7.6 kilowatt inverter output, and 34 kilowatt hours of energy. So really, really strong single solution from Generac. And again, simple because we have a single brand. Solar Edge. Okay, many of you are familiar with the Store Edge, which was the kind of first generation battery-based inverter that SolarEdge had. Now we've moved into the Energy Hub, and the Energy Hub with Prism Technology. And how does this Energy Hub work? The Energy Hub is still going to be where your PV is tying into with still using your P series optimizers. Then this is going to be paired into the backup interface, not the autoformer. So the backup interface includes an autoformer, but the backup interface is your new grid forming device. So we could kind of consider the backup interface similar to a smart switch or the automatic backup unit from SMA. So with the backup interface, you can stack up to 3 Energy Hub inverters. I believe we're still awaiting a firmware upgrade for that to be enabled, but the backup interface can support stacking, if you will. And then with SolarEdge, you're going to have your batteries. You can have up to 2 right now paired onto your Energy Hub. So you guys are probably familiar with this. SolarEdge's technology is consistent with what they've done in the past. They're just expanding by adding the backup interface to enable stacking. Okay, back to the Skybox. Here's another delightful schematic. And I like this because we actually can pretend like this is a real installation. So in this case, this is a rapid shutdown box. And you know, brands kind of approach rapid shutdown differently because not all rapid shutdown is necessary. I mean, what if you have a ground mount? You don't really want to worry about rapid shutdown if you have a ground mount because you don't have to. So in this case, we're doing a roof mount and we're putting on the Outback's rapid shutdown combiner box with their initiator. And that's tied into our Skybox. So in this case, the PV is going directly to the inverter. It is not going through a charge controller or a grid tie inverter because it can go straight into the Skybox with its built-in charger. Here is an example of an Outback battery stack. And this is, if I had to guess, this is just their IBR4, which is called their integrated battery rack. IBR2, because it's a 2-shelf unit. So the IBR2 can support 8 batteries. These look like AGM ones. Great. Panasonic Everbolt, very similar solution. Solar panel, here it says module level power electronics optional. Since we're really thinking about this as a DC coupled option, we're gonna just go straight from the solar panel into the Everbolt solution. If you need rapid shutdown, you can throw in like an AP Smart rapid shutdown compliant device. That would work. We're feeding our Everbolt with DC from our PV, with DC from our battery, and then you're feeding your essential loads alternating current. So really, this slide is going to be solutions that have just kind of your typical DC input where rapid shutdown would be from a third party. Solar Arc. So here, I like the way they've kind of laid this out because the wiring box is down below, similar to the way the Outback Radian uses the GSLC and the way the Skybox has their integrated wiring box. So all the wiring is done down below. And now we're going to just go all the way across. We have our 48-volt battery bank. Again, any kind of battery technology you want with Solar. We have our DC input for our panels. We have a battery temperature sensor. Great. Rapid shutdown signal. Great. I should stop moving my cursor so that will go away. Okay, limiter sensors. Generator start. So again, generator integration with Solar. CAN bus RS485, which is our communications protocol. Then we have our critical load panel because, again, even for DC coupling, we may still only want our critical loads rather than a whole house backup. You're still going to include wiring to the main panel. And then we have another, so here's the generator start module, and then here's our backup generator feed in. That makes sense. So if you need rapid shutdown with Solar, again, not a problem. You can just tie in a third-party rapid shutdown solution onto your solar panels before you feed the PV into the PV input on Solarc. Last but not least, kind of our most traditional solution, which is DC coupled with a charge controller. This is a really, really nice piece of equipment from Outback. It's called the Flex Power. So the Radian Flex Power is a pre-wired solution that includes the Radian. So here's our Radian inverter in the upper left. We have our GSLC wiring box, but it's mounted on a back plate. So everything is pre-wired. We have, in this case, 2 charge controllers already wired into the GSLC. And then we have our mate communicator, monitoring device. So all of this is already installed. The GSLC has all the breakers in there. So this is kind of making things way easier for you. You just mount the back plate onto your wall and then you're good to go. Energy storage, feeding your GSLC, great. The output, the AC output of your Flex Power Radian is going to feed your sub panel. Great, kind of everything we've seen before, but in this case, our PV is going into the charge controllers because we have an external charge controller in this instance. Magnum, great. So we have our Magnum panel, or our PV panel feeding the, let's just say it's the PT100 charge controller. And then here is the MMP is called the Magnum Mini Panel in this case, and that is like our GSLC or our Schneider Power Distribution Panel. Magnum has an MMP, which is the Mini. They also have a Magnum Panel. And the difference between the Mini and the regular panel is if you want multiple inverters. So you get a bigger panel if you know you're doing, let's say, a dual inverter setup. So you have your charge controller feeding the MMP, and the MMP is where you're going to have your Magnum inverter feeding it, your battery bank, the sub panel, and then the main panel. So again, really kind of similar to our Outback Radian or our Schneider setup where you have your inverter, then your separate load center, and your separate charge controller, kind of your traditional 3 main component setup. Here is their auto generator start little add-on, their battery monitor add-on, and then the remote controls are the RC or the ARC. Back to Schneider. So here we go with our photovoltaics feeding your charge controller. Let's say it's the 8600 or the 100-600. And then here, the distribution panel, let me think about this. We're going into our PDP. Yeah, this is our distribution panel, our power distribution panel. And this comes in a mini or a regular as well. So this is where you're going to be feeding your battery, your generator if necessary. The system control panel is a way to program your setup. So it's another screen in addition to the screen that's on your XW Pro. Then not pictured is the gateway. The gateway is your communication enabling device. So for Schneider, their communication is through the Insight, I believe Insight is the name of their software. So the gateway connects all of your XW products and sends that to the cloud so that you can monitor it remotely. So here is our charge controller, Pro inverter, and power distribution panel. We've done it. That is all of our AC and DC coupled options. So here is the